Good. Okay, recording is in progress. So this is Algebra PSS, so there really isn't any theory to cover. I'll be doing a bunch of random inequalities and their fees. Um, yeah, that is it. All the theory has been covered in previous classes for this. Uh, if you have any algebra problems you would like me to do, you can, I don't know, send them in chat or something. Otherwise, I have enough planned out for this class. You don't need to worry. Okay. So let's start with an easy one. Oh, this P3, by the way, doesn't mean it's like a P3 of a contest. I like listed all the problems in overleaf that I wanted to do in class, and this was the third one I listed, but it is the easiest one. So, okay, I'll give you anyone who has the idea, just speak up. Any ideas, etc. This really is just a problem solving class. I don't need to do much. Combinatorics, maybe after class. I can't cover it right now. Oh, wait, why is this not working? Ah, I is this pad like out of charge? Oh, okay. Oh, I'll just use trackpad today. This seems to be skill issuing. The first time seeing any problems. Any hints? I mean, wait. Okay, let's work. No, I'll give some hints in like a few minutes when let everyone try. But wait, Kushagra, have you seen any inequalities before?
Yeah, I've attended your classes of inequalities.
Yeah, so this is try to think of like the normal things in inequality. Also, the weird thing about this inequality is like, well, everything is weird. There is no symmetry, there is nothing. Hmm. Yeah. Okay, everyone, first thoughts. Okay, someone in chat is saying you can also unmute, but the thing under the square root should be positive. We can use that. Okay, correct. So we have y minus x square minus. Also, notice this is not a proof problem. This is a find all pairs of real numbers. Uh, honestly, this is basically a J problem, but it appeared in an Olympiad. I can put this in this class. Don't sue me. The Grand Duchy of Lithuania, a very respected contest, definitely. Okay, so this is the first thing, as someone pointed out. Any other thoughts? Transpose and square. Yeah, squaring here is slightly like the bad thing is you don't know anything about being positive right now, right? With y greater than x, why? Thing is, it's real numbers, it's not positive reals. So like number one, squaring already introduces extraneous stuff. You don't know 3xy minus like inequalities aren't preserved in the squaring if they involve real numbers. Substitute the value of xy as no. Can you elaborate on that? Iman? Rose? Hmm? Any way to homogenize? There is no condition given. xy less than equal to yes. Okay. This Rijul. Hello, Rijul. Yes, I thought this would be a great example to teach these students. Yeah. This is Rijul, would you like to comment about this problem in the chat? Okay, so we have xy less than equal to x square minus y. So, Iman, you're saying to substitute this here, I assume. So that gives us. Okay, writing on trackpad is very annoying. I should get a mouse. Plus square root y plus x square minus xy. So this is less than equal to 3xy, and xy is less than equal to y minus x square. So this is less than equal to 3y minus 3x square. I think this is what you were saying. Okay, so what next? I mean, it might. I'm not saying anything. It might work. X equal y equal 1. Does that work? This side becomes 0. No, that's not a solution. This thing just becomes negative. Let's just get a mouse. I think. I think what should work. Also, guys, unmute and speak up, please. Yeah, randomly trying is fine. Give me a second. Hmm. What are the equality cases? I'm not telling you. No hints yet. I mean, can you see any equality cases? Zero, zero. Zero, zero is an equality case. Zero, zero works. Okay, I have a mouse. This will make my life much easier. Okay, so let's start with some hints. So we use the fact that the thing under the square root sign is positive. What else can we say about square roots? Like their domain is positive, only the like non-negative reals. What about their range? Choosing variables which turn out to be.
So it also gives us that 3xy minus y squared minus y should be greater than or equal to 0, right?
What?
It also gives us that 3xy minus y squared minus
Yes,
should be greater than.
correct. So the range of square roots is also positive. So we have. Oh, this is just much worse. I'll just use trackpad. So 3xy minus y square minus y. Since this is greater than equal to a square root, and square roots always output positive reals, non-negative reals, this is also greater than equal to 0. So we have 1, we have 2. Positive equal. Yeah, whenever I say positive, it means non-negative. Like, don't worry about it. So, okay, so we have these two inequalities. What can we do with them?
Add an SF50.
Just add directly? Like, okay. That would cancel the y. That would give you 2xy minus y square minus x square greater than equal to 0. So what can you say about this?
So sad.
Multiply by minus negative on both the sides.
Okay, that's like, you don't need to say that many words. You can just directly like I know what you're trying to do, but you can directly say this. Yep. Yep. So x equal y. Okay. X must be equal to y. Now we'll now finish. Now what can we do? By the original was
Just
adding. Yeah, Keshav?
just substitute x equal to y in the original thing and solve it.
Sure. I mean, just solve it is doing a bit of heavy lifting there, but that is the first step. Iman, do you even know that all x equal y work? We
It,
have proven.
you just try it out, I guess.
Okay, sure.
Yeah.
I'll substitute y square equals. So we have y square plus y. Y minus 2y square. Less than equal to only x equal y equals 0. So yeah. You can think that. Okay. Ooh. Y minus 2y square is less than equal to 2y square minus y. There's a square root here. There's not a square root here. But what does this mean? Yep. You said this. So, okay, Kushagra, you are wrong though. Like that 0, 0 is not the only solution. There. So yeah, as Kumar Roy, I'm sorry, I can't pronounce your first name. Correctly pointed out. So this thing has to be positive. So does this thing. But these are negatives of each other. So they're both 0. So that means either y is 0 or y is half. So the two solutions are 0, 0 and half, half, which you can clearly check work. Yep. Any doubts? No. Is Rachel still in the chat? Yeah. Rachel, can you tell the class what you try to do here? Okay, anyway, I'll get problem to tell. Rachel tells his story. This is so not. This is the reason I'm doing this is because this has trolled multiple people. Some Sometimes there will be problems in Ollie which are just fake. You have to stop respecting them. Wait, what problem? Okay, let's do this simple FE. This problem also trolled the Archit, by the way. He was also trying the same things. Very troll. Okay, now for an actual Olympiad algebra problem. Here's a nice FE. And this time it's from an actually respected contest, not Grand Duchy of Lithuania.
Yeah, so f of 0 equal to f of 0 squared.
Uh,
I mean, that's the first thing you do in an FE, right?
yeah. So like you put 0, 0. So p 0, 0. So f of 0 equal f of 0 squared. So I know function a little bit. So like try putting. Okay. No, that's. So f of 0 is 0 or 1. Kushagra, you can't actually do that because you don't know that f will be a polynomial. I don't know if you might do another one. Okay, sure, it's fine. Oh, you don't have to leave. We can give you like an inequality also if you have a lot of problems. Shreya, y equals 0. Interesting. Shreya also. Oh, by the way, like guys, don't be intimidated by the source. This does not exist. Just ignore it. Okay. F of 0 is 1. Wait, why? Wait, let me see. 1 by 1. So what does f of x comma 0 give? That gives f of x equal f of x times f of 0. Okay. Yeah. Actually, not exactly. Like what you are given, if f of x is non-zero, then f of 0 is 1. But f of x can always be 0. Does that work? Mm. Think about that. If f of x is always 0, then this is always 0. This is always 0. So xy is always 0.
So f of 0 must be 0, right? With this.
Yeah. No, the point, okay, so when you have this, you want to cancel out the fx, so you get f of 0 equal 1, right? You can't cancel out fx if f of x happens to be 0. So if there's, wait, is someone in the mirror randomly? Oh no, someone's, don't do, I don't know how to get rid of it, whatever. Yeah. If f of x is ever non-zero, you can cancel it. Right, uh, Bhartijit, can you not do that? Wait, how do I get rid of these? Wait, how do I clear annotation? Can someone explain? How do I prevent annotation?
It will be annotated on the Zoom
Yeah,
interface, not on your.
disable annotation. Okay, how do I get rid of the annotation that's already happened though?
I think you have to go to the shared screen part and go to annotation and just erase it. That one.
It is. Okay, good. Thank you. I am very old. I do not understand how Zoom works. Okay. Anyway, but it was you who did that. I can see the name. It's fine. Anyway, yeah. So you can cancel out fx unless it's 0 everywhere. And so you want to prove that it's not 0 everywhere. And that's simple because the 0 everywhere function doesn't work. Right. Implies f of 0 equal 1. Yeah, everyone sees how we got f of 0 equal 1?
By the way, is the solution f of x equal to x plus 1?
F of x equal x plus 1 is one solution. I'm not saying if it's the only solution. The function may be odd. That doesn't change anything. Right? Wait, I'm not sure what you're trying to say. Okay. So now you have f of 0 equal 1. Try to use that. What can you do with it?
P of x comma minus x or something?
Good, good. So we want to use 0. So we've set x plus y equals 0, i.e. p of x comma minus x. So what does this give? This is f of 0, that's 1 minus x square. Your camera seems to be on gimbal today. What does that mean? Why can't we have f of x equals as 0 for all x? I'll explain that again. Wait. 1 minus x square. So you get this. Oh, by the way, 1729. If f of x is 0 for all x, then in the original equation, this is always 0, and this is always 0. So you get xy is always 0. But you know for a fact xy is not always 0. So fx can't be always 0. Is that clear?
Here we can put x equal to 1, right?
Yep. So x equal 1 implies 0 equal this one. Okay. What does this mean?
Either one of them have to be
One
0.
of them has to be 0. So what can
Yeah.
you do? Now you have new information. You know either f of 1 is 0. So case 1. So suppose you're in case 1. What can you do? Now you have a new information once again. So whenever you find a new value in fe, you plug it back. Try to use it. So what do you get?
1 comma y or something, or 1 comma y minus 1.
Perfect. So p of 1 comma y minus 1. So let's just see what this will give you. The point is now f of 1 is 0. So this becomes 0. And so 1 plus y minus 1 is just y. So you get f of y plus, yeah, f of x plus 1 equal minus x. And yeah, no, this is just, there is no theory. This is just a PSS class. So we are just doing problems. You just missed 2 problems. It's fine. Yeah. So you get f of y equal 1 minus y, if I'm doing it correctly. Yep. You get f of y equal 1 minus y. I hope I have not skill issue that. Yes, perfect. And in case 2, you instead plug f of, like case 2, you plug minus 1 and y plus 1. And you get f of y equal 1 plus y. And now final thing is to verify both these functions work, which you can do. They work. So yeah, this
Verification
was
is trivial.
verification. Do not leave that. This is a TST problem. You will lose 1 mark. They'll give you 9. I mean, this is a TST P2. Well, T4 P2. I think. Yes. So yeah, that's the whole problem. It's a TST problem, but it's actually just very simple FE. Okay. If anyone has any doubts, ask. I solved first in the TST of algebra. Of course. Yes. Okay. What's next? Let's do FE or inequality, guys. No, we are doing random algebra. Mm, FE,
We
FE
should
again.
alternate between them. Definitely.
Actually, alternating is probably better, so I'll inequality. Let's do this. People might have
What
seen
is
because
this?
this is a recent contest. I'll try. Do you have complex numbers? Uh, complex numbers, you can like they're used in problems, but they are not used in problem statements. Usually, like that will change. That hopefully will change soon. They're not. T2. Or directly T2. Don't even think. Sure, you can try that. You can directly apply T2. That will give you. That gives you some annoying stuff, right? So that gives you like the left hand side is greater than summation a square plus summation bc squared by 2 summation A. You can do this. But any other ideas are also welcome. Is all no, there is poly and sequences, but I do have one poly problem. I'll do it next, but I didn't find that many poly problems. Like the thing is, poly one like a poly one class has not happened yet, right? So that's why I'm only taking like Fe inequalities. You guys have already had a class, so I can do a problem solving session on them. But polynomials, you really haven't even had a class, which is why I was like hesitant to take polynomial problems. Like they are absolutely a thing. It's just I have not gotten problems of them. I can cover like one, I think. Anyway, so once again, you know the drill. Ideas. Polynomial and Fe are different. Can you explain? I'll explain. Okay, I'll explain after this problem.
Instead of T2, can we do some sort of
Hmm.
Cauchy-Schwarz?
Uh, some sort of you need to elaborate on that. What do you want to apply Cauchy shorts on?
So, okay, wait, let me think. This is so hard.
It's fine. Hamlet. This is a PSS, so like we are just doing problems. I have done 2 problems already, but we are doing this third one. You can try. Hmm. Anyone? Any ideas? You can also continue after the T2s, or if you have any other ideas, you can say them.
I think converting sigma a square plus bc to a plus b whole square plus b plus c whole square plus c plus a whole square might help. I'm not sure, but
Wait, can you repeat?
sigma a square plus bc is the half of a plus b whole square plus b plus c whole square plus c plus a whole square.
Okay, you can write
So
it at like that. So this will become like 8 summation A, and you're saying summation A plus, oh God, my writing sucks. I need to get the path thing working again. Can't do it like this. Okay. You can write it like this, although that I don't, okay, that might actually help a bit. Yeah.
What have you written? Can you just read it? See what it-
What, Aksar? I can't hear you.
Can you
Akshar?
read what you written?
We have just rewritten, like, you take this side, by T2s it's greater than equal to this expression, and then you rewrite this expression in this form.
What have you rewritten it as?
Summation A square plus summation BC, you can write that as half summation A plus B square.
Yeah.
And then at like half becomes 1/4 and that becomes 1/8. And so it's just summation A plus B square whole squared.
Yeah, so I figured out the quantities for coefficients.
Okay, what are they?
So uh, you take square root b plus c. So you take one sequence to be square root b plus c, comma square root c plus a, comma square root a plus b, and the
Okay.
second sequence to be uh,
Hmm.
the second sequence to be a squared plus bc upon square root b plus c and so on.
Okay.
So when you sort of square it, you should get some nice stuff. Right?
So you will get you'll get summation A square plus BC on one side, uh squared, I guess, is less than equal to, am I applying Cauchy shorts right? Yeah. 2 summation A times summation A square plus BC squared by B plus C. Is this what Cauchy Schwarz gives? Keshav?
Yes, I think so. So the
Yeah.
it is right.
It is right. I don't know about this. Does not like you get A square summation A square plus BC less than equal to
Yeah.
something. I
It's right.
want,
It's right.
but like I don't know if it helps because like you don't want this quantity. You want like this quantity divide B plus C less than equal to something. Okay, try to think of, okay, wait, let me give a hint. You have ABC in a product here. And okay, as a general bit of intuition, the more mixed terms are, the smaller they are in inequalities. Like A square plus B square plus C square is quite large. AB plus BC plus CA, which is more mixed, is smaller. And like ABC is even smaller. Well, not exactly, okay. ABC is 3 degrees, so it's larger, but the general intuition is the more you mix terms, the smaller they get. So thing is, terms are already very mixed here. So this side is already very small. So you can make like some pretty bad estimates on this side. Like Cauchy-Schwarz, Tito's lemma, they're like very strong estimates. You can do something smaller. Something even like very stupid. Okay, can we use ABC equal 1? Okay, so ABC isn't given to be 1, but since this inequality is like homogeneous, you can just assume it to be 1 for convenience. So yeah, you can. But once again, I don't know if that will be useful. Okay, Stupidest thing you can do. I used AMGM and 32. Okay, Kushagra. Uh, what did you use AMGM on? We can, Alex, we can. There's no issue. Oh, why can? Okay. I'll explain the homogenization part a bit. Let me just explain the solution first. With Kushagra, what did you use AM? I think you have the solution. Can you just tell what you used the AMGM on?
Yeah, so like you can use that AMGM on A square plus BC. Like so, then using that you may get that A square plus BC is always greater than equal to 2A root BC.
Correct. So we have LHS
So
greater
like
than
you can,
uh
yeah.
we get 4 ABC summation plus C.
A
Okay.
upon B plus C. Yeah.
Okay. Now what do you use T2s on?
Like now you can use like now you can use
Uh, Kushagra, you're muted.
yeah, sorry, my mic was not working. So now you can use like T2s on that RHS to probably just move forward.
RHS. Oh, you're saying like T2s in reverse.
Yeah, exactly.
Okay, that will work. I'll just go in the forward direction, I think. Okay. So the point is you want sum of A plus B plus C in the numerator and like A, B, B, C, C in the denominator. So what you do is you multiply this by and then you just apply T2s. So this becomes 4ABC times summation A squared by 2 summation AB, which is equal to the RHS. Yep, that works. Okay, does everyone get it?
So this was a pretty weak bound, right? Because
Yeah, exactly. That's what I said. Like the intuition in this problem you have to realize is like this is very weak. Okay. Like there are two ways you realize it's very weak. First of all, it's a JBMOP1. Second of all, there's an ABC here. Also, like I would say in general for inequalities, you start by making the weakest estimate you can get. If that doesn't work, then you start like making stronger estimates. Don't just start by stronger estimates, just in like, because if the weaker estimate ends up working, this will just make your life more miserable. Always like, always hope the problem is easier than it is. Sometimes you will be right. Okay. So now I'll paste an FE and then I'll like answer a few doubts like why can you set ABC equal 1 and the other one that someone asked. Uh, okay. I'll leave this here and wait. I'll quickly explain why you could have set ABC equal 1. Okay. And who asked? Alex. Okay, so Alex, that inequality was homogeneous. That is to say, okay, let's look at this in its another inequality. A square plus B square plus C square greater than equal to like summation AB. Okay. Now this inequality is homogeneous in the sense that everything here is degree 2, everything here is degree 2. So suppose you have proven this inequality for like some numbers A, B, and C, like not all, just some numbers, right? Then you don't need to prove it again for 2A, 2B, and 2C, right? Because the point is, if you put 2A, 2B, 2C here, then everything is the same degree, so the 4 just cancels. So the inequality at ABC just implies the inequality at 2A, 2B, 2C. Like, you can scale numbers by a constant factor in homogeneous inequalities, and they are still true. Right. So you only need to prove them for one of these. So that is why, like, what you can do arbitrarily is like set something like you can, if you prove the inequality for any all pairs, all triples of numbers a b c such that a plus b plus c equal 1, then you are done. Because for any other triple, like if there's a triple such that a plus b plus c is 3, right? Suppose there's this triple. Then you have already proven the inequality for a by 3, b by 3, c by 3. So it implies the inequality for this because it's homogeneous. And similarly, you can like set anything arbitrarily, but like only one thing. So you can also set ABC equal 1. If ABC happens to be 8, then just you have already proven the inequality for a by 2, b by 2, c by 2. So you directly get the inequality for ABC by scaling. Is that clear, Alex? Yeah. Okay. Nice. Anyway, so now we are back to alternating. Oh, I was supposed to give a poly. Okay, after this, I'll give a poly. Till then, try this FE.
We can easily get that either f of 1 is 0 or 1. And with that, if f of 1 is 1, then we get that f of any natural number is itself. So f of n is itself where n is an natural number.
Mm-hmm.
But
So
we need to eliminate the f of 1 case. Sorry, f of 1 equal to 0 case, because that shouldn't be happening, right?
that
So
was correct.
Yeah, doing that is easy.
Yeah, go on, Keshav. How do you eliminate it?
So f of 0 is either 0 or 1.
Yeah, and then
And then in the second equation, you put x equal to 0.
yeah, so f of 1 has to be 1 plus f of 0, and both numbers are 0 or 1. So f of 0 has to be
Yeah,
0, and 1 has to be 1.
yeah. And then you
And
can induct.
yeah, that gives you for all naturals. In fact, you can also go down. So all integers is our identity, but all numbers are not integers. It is the great tragedy of life.
Can you scroll up?
Okay, wait. Yeah, here's the problem statement. Just with induction, you can get all integers as 1. 1729, like you put 0 and you put 1. So like you get f of 1 is 0 or 1 and f of 0 is 0 or 1. And since f of 1 is 1 plus f of 0, like the only possibility is f of 1 is 1 and f of 0 is 0.
anyway, would this work if you put in x is equal to some like x squared? I mean, if you put x is equal to x squared in the second equation,
Right.
it will give us f of x squared plus 1 is equal to f of x plus whole squared plus 1.
Right. You're putting, okay, let's call the first statement like P, the second statement Q for simplicity.
Q of x squared.
So Q of x squared gives you what? F of x squared plus 1. Put by P. No, the thing is you don't know yet that wait, degree of input of P, right? Wait.
Like if we take an f of x squared term, then we can replace the x squared by x using the p condition.
You can, but not how that doesn't exactly like help you much, right?
I mean, we can prove that for all surds, that is not even surds, just like square root of natural numbers, the identity function holds.
Okay, how?
Like instead of putting x as x squared, that was sort of not necessary.
Hmm.
Uh, if you just put x as meaning in the second equation, which is the q, your f of x can be replaced by f of root x the whole squared, right?
F of x can be replaced by f of... Okay, I know what you're trying to say, but you can just directly do it in P.
Yeah, that works.
So you're saying P of root n, right?
Yeah, right.
So P of root n implies that the f of root n squared is n. That gives you f of root n is plus or minus root n. How do you eliminate the negative case?
All positive real numbers have to be greater than 0 using P1. Because if f of x square is equal to something squared, then it has to be greater than 0, and x square is any real number, any positive real number.
Perfect. That is correct. Is f of x. Oh, yeah. X greater than equal to 0. Yes. Have I have started this for no reason. Also, this solves our previous issue. F of root n can't be minus root n. It has to be plus root n.
Wait, how is f of x greater than equal to 0, x is greater than equal to 0?
Mm, put square root x. So f of x is a square. Squares are greater than equal to 0.
Yeah.
And square root exists if the number is positive. That's why you require x greater than equal to 0. I accidentally annotated. Oops.
So I mean, we also get that f of uh, n to the power 1 by 2 to the power k is also identity, right? Because you just apply the same argument again and again.
F of?
F of n to the power 1 by 2 to the power.
You get that. But I mean, you can keep doing this forever, but you're only ever going to get countably many numbers from this. You need some way to extend to all reals. So like, that is true, you can get a lot of numbers, but like that's not really that helpful. You need some big jump to get to all reals, which is why I'm like not writing it down. Like you can do a lot of like other clever things and you'll get a lot more like weird numbers. I think you can get like all numbers of the form a root n plus b or something. But once again, those are always countably many numbers. Like you will never be able to get a transcendental number. Just induction to prove on all integers. Is it possible to use induction on reals anyway? On reals is not possible. Well, okay. If someone ever mentions transfinite induction, I just ban them. Like, it's not a thing. Transfinite induction is a lie. Induction was only meant for naturals. If you don't know what transfinite induction is, don't worry about that. That's just a meme. Okay. Any other ideas?
I've
So what?
gotten a thing
Hmm.
which looks like Cauchy's, but I can't proceed.
What do you mean looks like Cauchy's?
Okay, let me tell what I did. So, I put x plus 1 whole square in the first equation.
Hmm.
So, I got f of x square plus 2x plus 1 is f of x plus 1 whole square.
Wait. Did you put x plus 1 or x square plus x, like x plus 1 square? Did you put this or the square?
Wait a second. Uh,
You somehow proved f dash x equal 1. How?
How
Like
is
for
even differentiable? What is
how did you get that? Like, if you get that, you're done. I haven't. How did you do that? What? What first principles did you use?
okay, so after this, I excluded one out. I took the one out with the second equation.
And so you're saying this will be like f of x squared and okay, plus f of x f of 1, which is just f of x. Oh, into 2 plus 1. And yeah, and this looks like Cauchy, right?
No, I don't think we can take f of x out. I mean, that should be f of x square plus 2x. X square plus 2x should be in that f, in the single f.
No, no,
Because I don't.
you write f of x plus 1 as f of x plus 1. You do it beforehand, right? Um,
for f of 2x? How did you write it as 2 times f of x?
no, it wasn't f
Yeah,
of 2x, right? This is just this. I did using calculus. No, I need elaboration. How do you even know the function is differentiable? But don't want to tell. Okay. All right, then. Keep your secrets. Yeah, and then you get this, and then this just is this. Right.
yeah, and I cancelled one in the LHS also. So I got f of x square plus 2x is f of x whole square plus 2f of x, which looks like Cauchy's, but
Create the whole do it. Yeah, this looks like Cauchy, but it's like much weaker than Cauchy because we don't have general A and B. We have x square and 2x. Like, looking like Cauchy isn't enough. If it's like this restricted, you really can't do much. In fact, in this whole problem, you should like realize this. There is really no way to get to like weird numbers. Like you can get to root n, you can get to like n to the 1 by 4 or whatever, n to the 1 by 4 plus 1 even, but it's quite like there is no real way. Like, how will you ever get to pi? Is my question. Does it feel like can you ever get to a transcendental number by just applying these equations over and over again? No, right? You'll always be like getting some squares and square roots. So you're like non-algebraic. Yeah, Kushagar, that's yeah, we already did that, I think. That's just an action. Yeah. Non-algebraic numbers like you can never get to. Right. Does everyone understand the issue? Yeah. Monotonically increasing. I don't see what issue is pi. And all other transcendentals. So like maybe you can do some very clever things to get to even all the algebraic numbers. I don't care. But we want to get to all reals. And there's is seemingly no way. And in fact, if this FE was like a complex to complex FE, then there would be like Actually, no way. The problem is wrong. There are other solutions. The one thing we have about real numbers that we have to use here that complex numbers lack is this positivity. This is our most important. Like, this is the only fact that we have like been able to prove for numbers that are not algebraic. Every other fact we have is only for algebraic numbers. Huh, if we can prove increasing, we are done. But once again, how? So this is really the only thing you have that you can prove for all reals so far. Every other fact we have, we are only like proving for very specific cases of reals, like root n being root n being n. Only this we have everywhere. Try to use it. Huh. Like you will be done, Anirudh, but I mean, not exactly. That still doesn't finish. But once again, that's way too wishful of a thinking. How will you ever prove monotonically increasing? Like that's good intuition, but the thing is, looking at these statements, proving anything like monotonically increasing seems very hard. Fx plus 1 greater than fx, yeah, but plus 1 isn't enough. You need like for increasing, you need everything. Okay, so let's give some hints. Okay, so we already know that like f of, okay, let's continue with pi. Let's prove the problem for pi. We know f of pi can't be minus 3 or something, right? We have proven f of positive is positive. Okay. Can f of pi be 2?
No, it can't.
Why not?
So, because f of, you can use the first condition and put x equal to 2, right? You know the value at, so f of 4 is equal to f of 2 whole squared,
Okay.
right?
Okay.
Wait, no, what am I doing?
It's some other reason. Like the biggest hint, as I said, is the fact this is the only thing you know about real numbers. Everything else, every other statement you have is like way too restricted. Okay, Kushagra, say your calculus solution. Okay, limits are okay. What is it?
So as like from the second condition, we get that f of r, like first of all you take that r is the like you take that x is equal to n plus r, where r is just like the fractional part. So I found out that like I've seen such a problem, and introducing the fractional part
It's fine. It's fine. Like,
turns.
continue.
Yeah, so like you get that if R is like just a member of the set 0 to 1, 1 not included, then you get that f of R raised to the power of 2 to the k is equal to f of R, and then that is raised to the power of 2 to the k.
Huh. Okay.
Yeah, and like so now here comes the tricky part. Like I am not sure whether it's right. Like
Uh,
as k grows, you get
uh,
that r to the 2 to the thing like just tends to 0.
uh-huh.
But like since f of 0 is equal to 0, so the left
No.
hand side tends.
Just because the input tends to 0 doesn't mean the output tends to f of 0. You don't know f is continuous.
Yeah, that was where my doubt was.
That will not work. How to improve at algebra? Do problems. That's the only advice. Yes. Okay. F of pi equal to. Okay. Given f of pi equal to, which other numbers can you find?
F of e.
What?
Powers of pi and pi plus k
I
or
do not
something.
care about like something even more simple than powers. We have two conditions, guys. You don't have to just
Pi
use the
plus 1, pi plus 2,
pi plus
pi
1, pi
minus
plus
1.
pi minus 1. So we have f of pi minus 1 equal to 1. And then,
F of pi minus 2 is 0.
okay, one more step.
And f of pi minus 3 has to be -1. But that is incorrect because pi
Pi
minus
minus
3 is,
because pi
is
is
greater, has to be greater than 0.
pi is greater than 3. Yes. And hence pi f of pi can't be 2. So in general, what bound does this prove on any f of n? Sorry, f of
It has
x.
to be greater than its greatest integer, then its integer part.
Yeah, so if x is x integer, we are already done. So if x is not an integer, then f of x is greater than equal to floor of x. Because otherwise you will get, no, sorry, greater than equal to. Yeah, not proven greater than. Perfect. Because otherwise you will get f of x minus floor x, which is positive, is equal to a negative number, which is a contradiction. Now we are getting close. So, okay, let's. How do we do that away? Let's see how else. What else can I motivate here? Hmm. Okay. Suppose f of minus pi is 1. This doesn't like immediately give you any issues, right? Because the floor of minus pi is 4 and 1 is bigger than 4. But once again, given f of minus pi is 1, what else can you get? Like now addition will not give you any issues because like f of x greater than equal to floor x is satisfied. So now we try to use the other thing we have, squaring.
F of pi squared has to be 1.
Correct? And is that possible?
That's not right because pi squared is should be
No, it's not possible.
greater than equal to 6 or something. Not
Greater
6.
than equal to
It
6.
has to be 1 plus 6.
It's G, bro.
It's
It's
not
just
possible.
10. It's 9, but whatever. Yes, so this is wrong. So what bound does this give you? Like, now generalize this argument. What can you conclude about fx in general?
F of minus x has to be greater than or equal to floor of x. No.
Okay, let's just do the argument in general. Yeah, something like that. So take f of x minus x, where x is positive. So suppose this is t. Then you have t square equal f of x square. Right. And what am I saying? Yeah. T square has to be um t t square has to be greater than equal to floor of x square. T square greater than equal to floor x square implies t is greater than equal to, well, no, this implies like absolute value of t is greater than equal to this. So this is our second bound. In fact, this holds for like plus minus x. Like in both cases, you can conclude this. Right. So you get, in general, f of x absolute value is greater than equal to square root floor x square. Is that clear? Sorry. What? T square should be... Wait, I think I made a mistake. Oh, that's fine, right? This is correct?
Just a question, by the way.
Yeah.
Just a question. What if t is like smaller than 1?
What if t is smaller than 1? Then like we have an issue. Right.
So does this hold for only x greater than 1
No,
or
it
smaller than
always holds,
1?
because the point is if t is smaller than 1, that implies x square has, like, this thing has to be 0. That means x has to be in minus 1 to 1.
Right.
Okay. So now the point is, given any like f of x.
Wait, so one thing.
Yeah.
The root of floor of x squared is always less than or equal to floor of x, right?
Root of floor of x square. Always wait. Floor x square great less than equal to x square. So small x. Okay.
But does this bound even help us?
Yeah, it seems like this is a weaker bound, right?
Yeah.
The good part is the absolute value here. Like, hey, look, the bound did help us for f of minus pi.
Okay, yeah.
The thing that's helping us is now like we get an absolute value here. Previously, we did not have that. So in general, suppose we have some f of x. Let's see what we can say. Suppose we have some f of x equal, then it has to be greater than equal to floor x, right? In fact, wait, let's give a more, how do I give a more instructive example? Okay. Yeah. Take f of pi equal, now let's say 4, right? Right. So now we have, let's draw a table. Pi maps to 4. Pi plus 1 maps to 5. And so on. For positive numbers, these are all like fine. Let's go down to the negatives. So we have like pi minus 4 maps to 0. Right. But we have this bound. The thing is, like floor okay, the thing that was messing with us earlier, like floor x, like if x is negative, floor x is also small. But if x is negative, then square root floor x square becomes large. So now we still get a bound that we weren't getting earlier. Right. So now what we do? So pi minus 4 maps to 0. So we know 0 must be bigger than, like 0 greater than equal to pi minus 4 square floor square root, which is actually true. That's also 0, but like go one step further. Take pi minus 5 and minus 1. What do you get now? You get that like floor, like absolute value minus 1, which is 1, must be greater than equal to pi minus 5 square root and the flow here. Right. This is what you get.
Yeah.
So what's pi minus 5 square? So like pi is 3.14, so this is like 1.8 something. So the square will be like 3 point something. No, not 3 point. Like it will be, yeah, it will be 3 point something. So the floor is 3. So 1 greater than equal to square root 3, which is a contradiction. Right.
Yeah.
Okay, so okay, now let you do something. I'll suppose we have f of pi equal pi plus epsilon for some epsilon greater than 0. Can like do a similar argument like I did here and prove that this is not possible.
Just go down by like epsilon plus 2 steps or something, and you should get the result.
Epsilon plus 2 will not actually be enough. You need to go down by like some large amount of steps, say capital N. So this is pi plus epsilon minus n. So now we have what? So absolute value of t, that will become n minus pi minus epsilon, has to always be greater than equal to square root floor and the square of this. N like minus epsilon minus pi. Sorry, there's no epsilon here. Right. So you get this equation, right? Yes. So this side, okay, wait, oh, I'm not looking at chat.
So for a large enough n, this is just simply not possible.
Yes, exactly.
Yeah.
People are saying, don't worry, the class I can take from earlier. I don't know which problem the contest is actually. Yes, so the point is, as you go as n becomes large, this side becomes like just n minus pi, while this side is n minus pi minus epsilon, which is smaller than this. So this is not possible. Like you have to do some work to prove that like this is very close to n minus pi, but that's not hard. Like the point is, wait, let me just do it. So n minus pi square floor is greater than equal to square root of n minus pi square minus 1, right? Simple problem made me. Yeah. And this is, yeah, now you can just see like this is square root x square minus 1, which is like basically equal to n minus pi. Like, and what do you want to do? You want to prove a contradiction, right? So yeah, square both sides. So you get n minus pi square minus 2 epsilon n minus pi plus epsilon square. It looks simple, but it's actually a very instructive problem. I'll explain more. I'll recap
After writing this, after writing this, can you please choose a darker ink?
Oh, I'm already using black. Wait, how do I zoom in more? That may help. I think that helps. Okay. Anyway, I zoomed. Okay. Just try to read for now. I'm sorry about that. But yeah, so the point is this cancels. And so you get 1. Yeah, you get 1 plus epsilon square is greater than equal to what? 2 epsilon times n minus epsilon. But the thing is, this side is constant, and as you increase n, this side goes to infinity. So this can't hold forever. So that proves like f of pi can't be bigger than pi. And obviously there's nothing special about pi. This just proves in general fx less than equal to x. Is that clear? Does everyone understand? Yep. Now,
Yep.
the other direction. Now you can scam. So suppose f of pi was pi minus epsilon. These have reached here. Oh, sorry. No, wrong way around. Now suppose f of pi was less than pi. Now what? Okay, the class is almost over, so I'll just explain what we do. So now, what you do is you go a bit more down. Say you go to like pi minus 4. So f of pi minus 4 is equal to pi minus epsilon minus 4. Right. In fact, wait, let me just do a more instructive example. Yeah. So suppose f of minus 1.3 was equal to, we know it has to be greater than equal to minus 1.3. Suppose it was minus 1.4. Sorry, it has to be less than minus 1.3. Suppose it was minus 1.4. The thing is, now we can square both sides. So we get 1.69 is equal to 1.96. But now we have something mapping to bigger than it, which we know is false. Right?
Okay, so squaring it would just give
Yes.
it.
Perfect. In general, if you have any number mapping, like say f of pi maps to pi minus epsilon, you first go down. So you go down to a negative number. F of pi minus 4 is f of pi minus epsilon minus 4. Then you square both sides, and then instead of mapping to a smaller number, you have it mapped to a larger number, which we have already disproved. So we are done. Is that clear to everyone? So it's
Yeah,
equal.
sure, dear.
So fx is always x. Okay. So this was this difficult problem and took quite a while. So I'll just do a quick recap. So yeah, the main intuition you have to have in this problem is realize that these equations are like not telling you enough things about general numbers. Like keep applying these equations. Like in a general FE, I don't actually know the source. I would have to ask. Like Rijul gave me this problem once. Like in general FEs, when you have like two variables, x and y, you have a lot of freedom. You can like make them behave in like weird ways to get random cancellations. When you have a single variable, you can't really keep substituting that variable to be something to get stuff, right? Because once again, when you have a single variable, with that you can never get to weird numbers like pi. I'll always come back to pi as an example. Like squaring, adding 1, this only ever gives algebraic numbers. So you need to find something like that encaptures all real numbers. And that was this positivity. And once you have positivity, you need to like try to exploit it. This is a difficult problem, but you will get there. Like, so the idea, like the way I solved this problem was this. Like I thought that, okay, so obviously like I can't get to pi in any way. So first I noticed this positivity, and then I actually started doing these things. I was like, okay, So suppose f of pi was like 2. That's not possible because of this. So we get our first bound. Suppose f of pi was like, now we got a lower bound, then I wanted an upper bound. So I started in the negative numbers, and then I got this. And then I'm like, okay, with these two bounds, can I finish? And then I did finish. Like, this is what you want to like think about in this FE. So you want to prove X. So first you find some trivial inequalities, and then you try to exploit them. So, like, okay, I can't build intuition more than that. But the main idea is this: you can't do a lot of things. So you have to realize positivity is the most important part. Okay, I hope the intuition is clear in some ways. I know I didn't do that good a job, but with experience, you will slowly start to realize that like one variable FEs are really weird. Like two variable FEs, you can just do random substitutions. That will never work in one variable FEs unless it's really trivial. Its own calligraphy phone, thank you. If you say that. Okay. Like class time has technically ended, but I can do a few more problems if you guys want.
Yeah, I can wait. I can wait till 8 o'clock.
I don't know if everyone can. I mean, okay, you want? Fine. Anyone who can stay can stay. Oh, wait, what the hell? I posted the wrong problem. I'm not doing
But
polynomials. You just get a polynomials lecture later on. Let me find the actual problem I wanted to paste.
are you going?
But yeah, like if
Huh?
possible, like if you are not saving these problems for next PSS, like after class, maybe when you are free, can you like just post these problems which you had collected for like
Actually,
in
not. I'll
the
just do that
Discord?
right now. I'll post it in. Wait, let me post it in OMC. P sets and lecture notes. Upload a file. My dog's getting mad at me. Students. Okay. I have posted it in chat. If anyone wants to leave, you can go and like just try them yourself. Feel free to ask me for any hints/doubts. There are like 10 problems there. Okay. I'll do one more problem for those who are like still interested in the class. If you want to leave, you can leave. There's no obligation to stay. You try this problem. I'll go ensure my dog stops barking.
Like, did any one of you like wrote the polynomial problem because like a pop-up bar has come up? So can you tell me, please?
Okay. So this is a this is a problem we're doing. Australia MO 2024 P3. Okay, so first thoughts.
So this is just like intuition. This is not a solution
Hmm.
whatsoever.
Hmm.
But we could arrange these guys in ascending order. We could arrange A1, A2, so on in ascending order. and then try to get a clever permutation for which the summation becomes smaller or something.
Summation becomes smaller. Okay.
So
That.
like shift everything by -1.
Hmm.
So bi is equal to ai minus 1
Hmm.
or something like that.
Okay, that's an idea, but does not exactly.
But I think you would run into problems if an is too large or something.
Yeah, I mean, like, it may be entirely stupid to say that, but like, since
Hmm.
it says that the scores at least differ by this amount, maybe like, can we get that the difference of these two scores are greater than equal to the required value?
Which two scores?
Like it shows that, sorry, any two permutations like of this have scores that differ by at least like the given above. So, like, can it be like that we just choose some two permutations and maybe like get some bounding like greater than equal to? It may be entirely stupid, but
Okay. Okay, think about this. So we want to bound in terms of a1 minus an, right? Like our like the lower bound don't want it to depend on like a2 a3 at all. We just want a lower bound in terms of a1 and an, right? So what kind of permutation should we be picking? Like two permutations that.
Just exactly opposite.
No, the thing is exactly opposite changes a lot of things. Like if you pick the permutation a1 to an and then an to a1, then everything changes. Like a2 also changes positions, a3 also changes. So our lower bound will also depend on a2, a3, a4. Like maybe we can
So
work with it to like get it to only depend on a2 and a1 and an, but ideally we shouldn't have to do more work. Can we just directly get it only in terms of a1 and an?
yeah, just replace a1 by an and an by a1.
Perfect. Just do these two. Okay, wait. First of all, I'll assume n greater than equal to 4. N equal 2 and 3 cases, like, okay, 3 is identical to 4 and above, and 2 is trivial. I'll leave those two as exercise for the reader. For 2, what do we have? So, our first score is like a1 square by a2, like, plus a bunch of random stuff, which we don't care about, plus uh, a n minus 1 square by an. Every other term is independent of a1 and an, right? So when you replace an and a1, you get an square by a2 square plus random stuff plus an minus 1 square by a1. Right. These things are the same because we have only switched a1 and an. Correct. Okay, so what's their difference? What's the difference of score? Factor it out a bit.
A1 minus an times a1 plus an by a2 square.
So okay, so the difference, so like s1 minus, I'll call it s2, is, so it's a1 minus an times a1 plus an by a2. And what? Like this is the difference of the first two terms. Every other term cancels. What is the difference of the last two terms? That's just a1 minus an times an minus 1 square by a1 times an, right? So that will be uh, does everyone agree that the difference is this? Like score S1 minus score S2 is this. Oh, sorry, I'm not looking at chat. Wait. Can't even understand. The dog. Yeah, my dog was barking. With Kushagra, what's not clear?
No, yeah, now I understood. That was a little bit early.
Okay. Yeah, so I think everyone understands. Yeah. So we have A1 minus AN here, and we want to have this difference of scores greater than equal to 3A1 minus AN. So, like, A1 minus AN is already here. Like, take absolute value. I do not care much. Yes. So we want to prove that this thing is greater than equal to 3. Right. So this thing is A1 by AN, A1 by A2, plus AN by A2, plus AN minus 1 square by A1 AN. So what can we do with this? Like, we want to prove this greater than equal to 3. What's the, like, stupidest estimate you can
AMGM
apply?
or something.
AMGM or something. So you apply AMGM on 3 terms. So you get this is greater than equal to 3 times the cube root of A1 AN cancel. You get AN minus 1 square by A2 square. Now, if AN minus 1 was bigger than A2, greater than equal to, then we are done. Then this is greater than equal to 3. And then we go home. What if it's not? What if A2 is greater than AN minus 1? Then what do we do?
Does that case really matter? Because at the start, we can just set everything in ascending order, right?
Okay, no, the thing is, the problem fixes what A1 and AN are. Like, there is a permutation given to us, and A1 and AN are fixed in that permutation. Like, you can't change what A1 and AN were.
No, but you don't need to change AN and A1. You can just change A2 and AN minus 1, right?
Ha, perfect. Exactly. As someone in chat also pointed out, that does not matter at all. So instead of taking these two permutations, you take the permutation A1, AN minus 1, and like everything same, but AN minus 1 and A2 are flipped. And in that case, you get greater. And that difference you get is greater than equal to 3. So that's done. For n equal 3, what happens is A2 and AN minus 1 are just same. So you directly finish. You don't need to do anything. For n equal 2, it's like slightly more tricky, like because n equal 2, you don't have any a2 or an minus 1. One time the score will be a1 square by an, like just a2, and the other time the score will be a2 square by a1. Proving this difference is greater than equal to that is just AMGM. I'll let you guys try it yourself. So this is an equal 2 case, and that's n not equal to case. And you're done. Okay. So this was much simpler than the FE we just did. And does everyone understand? Anyone has any doubts? Oh, okay. I think everyone understands. So let's do another FE, but like a normal 2-variable FEs this time. I just wanted to do a 1-variable FE as an example, but most FEs you will see will die to random substitutions. Okay, so spam random substitutions. Go.
So f of 0
Lamau is
is
a
equal
contest
to...
very close to my own heart. What? F of 0 is?
Oh, wait, no. You have to put x equal to minus 1 to get f of 0 on the LHS, and then y equal to 0 to get it on the RHS, right?
I think this
So
was done.
minus 1 comma 0.
Wait, what was then? Was someone saying?
This question was done in the previous FE class. Intro
Oh.
to.
Oh, it was an intro to FE. Okay. I did not know that. Okay, so people who attended that class, I think you already know it. If you didn't, you can like watch the recording or try it yourself after class. If that many people have seen it, then I won't like try do it in class then. My bad. Keshav, did you attend the previous intro to FE class?
No, I did not.
That's fine. Okay, you can try this yourself. Like message me on Discord if you have any, if you want a hint, or watch
Okay.
the lecture.
Works. Works.
Okay, so okay, that's I don't have any more FEs. Maybe we just do another. I mean, I have that polynomial. I'll not do polynomial. You do. You have a polynomial class eventually. Okay, let's do some more scamming. Let's do another inequality. This is just an inequalities PSS at this point. Actually, no, half our time was spent on one FE. Oh, don't be scared. Okay, so what's the worst thing about this inequality?
There's no same degree. It's not
Okay.
homogenized.
Homogenization we can fix later. What's the other bad thing about this inequality? Cube roots. Correct. Someone in chat has pointed out. Cube roots are pretty bad. So you have a cube root a plus cube root b plus cube root c, and we want to prove it's less than equal to something. So like how, if you have a sum of cube roots, okay, like call this thing x. How do you deal with how do you like get rid of a sum of cube roots? Is there any inequality you know of? I think I might have like not covered this in inequality one, which is sad, but now I'm covering it. If anyone knows the inequality, just say it. AMGM gives cube root. Yes, but okay, muy head, yeah, but something very simple. Like cube root x plus cube root y plus cube root z. Can you get a bound that like gets rid of the sum of cube roots? Say this is the mean of cube roots. This is less than equal to. Okay, does everyone remember this inequality? Root a plus root b by 2. So the mean of square roots is less than equal to the square root of the mean. This is you can prove this inequality by squaring. Or like just AMGM, that's fine. Or my favorite proof is Jensen, but don't talk about that. So in the spirit of this inequality, what do you guess will be this inequality?
Cube root of a plus x plus y plus z.
Exactly. Yep. A quick word about the proof. So what you do is like, okay, so for this inequality, what you'll do is like take root a and root b as like your new variables, say p and q. So we want to prove p plus q by 2 is less than equal to p square plus q square by 2 square root. Now you square both sides and you just get AMGM. Right. Now you can do it in your head. Like you square, you will get p square plus q square plus 2pq here. And you'll get 2p square plus q square here. So this will become p minus q square greater than equal to 0. It's the same thing here. You'll cube both sides. You'll take everything to one side. And then you'll get like some variety of sum of squares and AMGM. I will not bother writing it out, but you all can try to prove this as an exercise. And the obvious generalization hold. You can do it with any nth roots. Okay. A slicker proof is by Jensen's, which will hopefully be covered in inequalities too, whenever that happens. Anyway, so this is, once again, this is a very weak bound, but as I said, you start with the weak bounds. Like, hope they work. If they don't work, then you get the strong bounds. This time you don't have the JBMO P1 hint. This is a A5. So you should think the strong weak bound doesn't work, but you'll be surprised. So the left-hand side is less than equal to, so you'll get 3 times the cube root of, what is it? 6 summation A plus summation 1 by A by 3. And you want to prove less than equal to question mark. This is less than equal to 1 by ABC. Okay. So this is the dumbest thing you can do. Now we have a single cube root. So what do we do?
I'm skeptical about cubing because the right hand side is smaller than 1.
Okay, but that doesn't change anything, right? If both sides are positive, cubing still preserves the inequality. In fact, cubing always preserves the inequality.
Oh, wait, right, cubing. Yeah, this cube.
Ah. Uh, in fact, like you should be wary about cubing if this was like 1 by A plus 1 by B plus 1 by C, because then you get a lot of terms. Currently, you just get a single term. That does not make that makes our lives better. So this is like this becomes 9. So okay, so I'll just write this. So this is 54 times summation A plus 9 times summation 1 by A less than equal to, okay, 1 by A cube, B cube, C cube. So what now? Wait, why is there a big, oh my God, I had that. Oh, wait, what? Okay, somehow I was doing this problem in the middle of another problem. That's fine. Okay. Next stupidest thing you can do. Okay, no, that's not even stupid. Just this is most simple thing you should be doing now. Multiply. So you get, let's see. Okay, I'll take 54 A cube, B cube, C cube times, what is it? A plus B plus C plus 9 times A square, B square, C square, and 1 ABC goes inside, and that will become summation AB less than equal to 1. Now, finally, we can use our condition. Summation AB is given to be 1. Oh, where were we? Yeah, I'll keep doing here. Ignore the big 2. So, yeah. So we have 54. Like, I'm just write the LHS product A cube summation A plus 9 product A square. Okay. We already used our condition once, but we want to be able to use it again. Like summation AB. We have a lot of summation, like AB, BC, CA, we know add up to 1. So can you write this inequality in terms of those numbers? Okay. Oh. Wait, where were we? Aadish, I want to talk to you. Can I? Sure, you can. Oh, there's like only like 5 people left, so I'll give a bit of a hint. AMGM 9 A square B square. Yes, okay. So you have the correct idea. So the point is 9 A square B square C square, like product A square, is equal to product of AB. Right. And product of AB, we know by AMGM, like we know sum of AB is less than equal to 1. So product of AB is less than equal to 1 by 3. AMGM. So you put this here. So you get this whole thing is less than equal to wait, what? 1 by 3? Oh, sorry. 1 by 27. And there's a 1 by 9 here, so this whole thing becomes less than 1 by 3. So you get 2. Okay. So you get plus 1 by 3. And here also you can like get rid of 1 A square B square C square. So that will become 2 times ABC, A plus B plus C. What can you do now? Oh, the mirror is getting crowded. Okay. I'll just tell you the solution because we are already 30 minutes over time, I think, and people have like mostly left. Okay. ABC times A plus B plus C. There's this very nice trick you can do. So, okay, I'll just. Also, I'm sorry about the Miro. It's getting a bit bad. If you notice, this is equal to AB times AC summation. And we know this is, yeah. Yeah, that's fine. Like, this is just something you notice a bit. Like, ABC times A plus B plus C, you can just write in terms of AB and AC and BC. And now, you know you have the pairwise product of numbers whose sum you know is 1. So the pairwise product by AMGM is less than equal to 1 by 3. Just use AMGM. Right, like. So this whole thing is less than equal to 2 by 3 plus 1 by 3 equal to 1. QED. Okay. I know that this problem I had to do a little fast because I was already over time, but this is a great example of just apply the stupidest estimates you can think of and hope everything works out. So the stupidest estimate, you have cube roots, cubic mean, get rid of it. Then you have like ABBCCA, AMGM, get rid of it. ABCA plus B plus C, AMGM, get rid of it. And you're done. Does everyone understand the proof / the motivation? Wait, Gulshan, you're saying Gulshan, do you have any doubts? So just try to, yes. Like, this will not work for you always. Like, harder inequalities usually like the simplest estimates just are wrong. But yeah, the first thing you should still try in any inequality is try to get rid of the ugly things. If that fails, then you use more advanced things. But always start with this. Like, this problem was 2004 A5. It was also India TSTP3. Like, this is a problem you would not expect the easiest estimates to work, but they do. Okay. So I think all but 3 people have left, which is, fine. I told you the class would end earlier. So can you use Muirhead without proof in RMO? I mean, should be fine, but like if you're using, you will not need Muirhead in RMO. Okay, tattoos is fine. Cauchy is fine. Holders is probably fine, but once again, holders you will not need in RMO. Cauchy and tattoo are fine. Like honestly, in RMO, you will not need anything beyond Cauchy, tattoo, and AMGM. I I can't. I'm not exactly sure about holder and Muirhead. Even like this kind of statements are fine. Like this also you can say without proof. Just a power mean inequality. Okay. If anyone has it, I like there are only 3 people. So do any of you have any doubts, or can I end the class? You can also like message me later on Discord if you want. No doubt. Okay. No, thank you for the class. No doubt. Okay then. I'll. This bunny is. As a thank you for staying so late. And now I'll end the class. How do I do that? Stop share. Close. Screen sharing has stopped.